So imagine you fire up your PlayStation 5, right? You just open up the official YouTube app.
Yeah, just settling in to watch a cooking video or something.
Exactly. But instead of an ad for car insurance loading on your screen, the console's underlying developer environment just sort of, it spills open.
Right, just completely exposed.
Yeah, granting you full access to restricted system files. I mean, it sounds like some glitch from a cyberpunk movie.
It really does.
But today, for this deep dive, we are looking at how developers are doing exactly that. They are turning literal video apps into these digital Trojan horses.
Which is just a remarkable display of reverse engineering.
Yeah.
Because, when you buy a modern console, the expectation is that it operates as a totally locked down ecosystem.
Right, like a walled garden.
Exactly. You've got hardware checks, software sandboxes, strict firmware requirements.
Yeah.
And they're all designed to make sure the manufacturer dictates exactly what that hardware can and cannot do.
But the homebrew and jailbreak communities, they kind of operate on the assumption that no system is flawless, right?
Yeah.
Like if you push the right combination of digital bricks, eventually a secret door is going to swing open.
Oh, absolutely. There's always a secret door.
And mapping out those secret doors is our mission today. We're exploring this really fascinating stack of sources. We've got developer change logs, GitHub repositories, security research.
Real cutting edge stuff.
Yeah, really the bleeding edge of PlayStation customization. So we're going to look at how developers are breaking into the system right now, how they build like complex automated infrastructure to manage games, and how Sony is actively fighting back.
It's a constant back and forth.
Right. So for you listening, whether you tinker with hardware yourself or you just want to know how seemingly impenetrable systems are dismantled and rebuilt, we are going to walk through exactly how this cat and mouse game works.
And to really understand the whole picture, we have to start at the perimeter.
Okay, the perimeter.
Yeah. Before anyone can run unauthorized software or, customize a dashboard, they have to find a way to get their code inside the system in the first place.
Okay. Which brings us straight to that YouTube scenario I mentioned earlier, which is based on a new tool in our sources called Y2JB.
Right. The YouTube jailbreak.
Yeah. And this is an exploit that achieves what developers call userland code execution simply by exploiting the PS5 YouTube app.
Which is wild.
It is wild. But I want to pause right there, actually, because userland is one of those terms that gets thrown around constantly in these documents. Let's define the stakes for the listener. What exactly is userland?
Sure. So think of the console's operating system as a massive corporate office building.
Okay, an office building.
Right. Userland is basically the lobby and the public meeting rooms. It's the surface level where everyday applications are allowed to operate.
Like games, streaming apps, that kind of thing.
Yeah, exactly. Games, the web browser, YouTube, they have restricted access. So they can't look at sensitive files, and they definitely can't change the building's core infrastructure.
Okay, so if userland is the lobby, what's the alternative? Like, what are they actually looking for?
The alternative, the ultimate goal for a full jailbreak is the kernel.
The kernel?
Yeah. In our analogy, the kernel is the CEO's office on the top floor, and it has the master keys to every single door in the building.
Oh, wow. Okay, so a userland exploit like this Y2JB thing, that just gets you through the front doors.
Right. It lets you run code in the lobby. You don't have total control yet, but you have a vital foothold. You're inside the building.
Okay, that clarifies a lot. So Y2JB gets you into the lobby using the YouTube app, and the sources say this works on firmware 4.03 all the way up to 12.70.
Which is a pretty wide range, honestly.
Yeah. But looking at the setup instructions, the process isn't just, clicking a button.
Not at all.
There is this very strict requirement where you have to go into the PS5 network settings and change your primary DNS, your domain name system, to 127.0.2.
Right. A very specific address.
And my immediate thought reading that was, wait, doesn't routing your DNS to 127.0.0.2 just intentionally break your internet connection? Why is that a mandatory step?
Well, what's fascinating here is that breaking the connection to Sony servers is the entire objective.
Wait, really? You want to break it?
Yeah, exactly.
Yeah.
When you set a DNS to 127.0.2, you are pointing the console's network traffic to a dead-end loop. It's called localhost.
Oh, I've heard of that.
Right. You are essentially telling the PS5 to talk to itself when it tries to look up external server addresses.
So it's essentially putting the console into a sensory deprivation tank. It can't see or hear the PlayStation network anymore.
That is a highly accurate way to describe it. Because think about it. If the console can reach the PlayStation network, it might detect that your system software is out of date.
Oh, and force a firmware update.
Exactly. Or Even worse for the developers, it might silently update the YouTube app itself in the background, which patches the very vulnerability they're trying to use.
Okay, so by blinding the console, you freeze the environment in place.
Right, you give the exploit time to work without Sony interfering.
Got it. And to fully execute this, the sources note you also need what they call a fake activated account. You can't just use your normal official PSN profile.
No, that would require pinging the servers.
Right, so you have to create an offline profile and use a utility in the Edehen toolbox to spoof its activation status.
Yeah, it's a very clever workaround.
It is, but it's a lot of hoops to jump through. But I think it highlights a recurring theme in the sources, right? The console's web rendering capabilities are almost always the weakest link.
They really are. And that structural weakness is highlighted by another massive development in the security research we reviewed.
Oh, the WebKit bug.
It's exactly. A new WebKit-type confusion bug released by researcher Nathan Fargo. And this one is huge because it affects PS4s on firmware 10.00 and above, and PS5s on 6.000 and above.
Yeah, whenever I see WebKit in these security documents, it feels like the holy grail for hackers.
It's definitely the most common entry point.
Right, and for context for the listener, WebKit is the browser engine that powers Safari and a lot of embedded browsers inside apps like YouTube. But why is this specific engine always the way they get in?
It comes down to the sheer complexity of what a web browser has to do.
How so?
Well, browsers have to download unknown, highly dynamic code from the internet, like JavaScript and CSS, and interpret it on the fly. Then they have to figure out how to display it and allocate memory for it safely.
Which sounds like a nightmare.
It is. It's an incredibly difficult engineering task, and mistakes just happen. Fargo's exploit targets one of those mistakes, specifically a CSS font face use after free bug.
Okay, let's unpack this for the listener. How does loading a font style crash a console's security? Like, that sounds crazy.
It does. But we can visualize the console's memory, kind of like a hotel.
Okay, I like a hotel analogy. Let's do it.
So when the WebKit browser needs to load a custom web font, a CSS font face, it checks a room out at the front desk. It puts the font data in that room.
Right.
And when it's done displaying the text, it's supposed to check out, freeing the room so another program can use it.
Okay, so far, standard hotel procedure.
Right. But in a use after free bug, the system makes a critical clerical error. It marks the room as free in the main ledger, but it forgets to take the original fonts room key away from the browser.
Wait, so the browser is just trusting that the key still matches the lock, even though the room has supposedly been turned over to someone else?
Precisely. And this is where it gets dangerous, because then a malicious script crafted by an attacker comes along, checks into that exact same freed room, and fills it with dangerous executable code.
What developers call a payload.
Exactly. But because the browser still holds the old key, it thinks that room just contains harmless font data. Yeah. So it inadvertently reads and executes the dangerous payload. That memory confusion is what lets the attacker break out of the browser's sandbox.
That is brilliant. It literally uses the system's own efficiency against
That's
it.
very elegant.
But reading the documentation, Nathan Fargo does point out that on the PS5, tricking the memory hotel isn't exactly a silver bullet.
Right, because of ASLR.
Yeah, address space layout randomization. So even if you hold the old key, the PS5 constantly shuffles the room numbers around.
Exactly. It's a security mitigation. So you need a secondary exploit just to figure out where you physically are in the memory before you can execute the payload safely.
Oh, wow. So it's an important caveat. A WebKit bug gets you into the lobby, but ASLR puts a blindfold on you once you are inside.
That's a great way to put it. You still need a map to do anything useful.
Okay, but let's assume you've navigated all of this, right? You've smuggled your payload through the YouTube app, you've survived the memory hotel, you figured out the map, you have userland execution.
The hard part is over.
Right, but sitting in an empty digital room doesn't let you actually play backed up games or modify the system, right? You need a way to unpack your bags and make the space functional. You need tools.
And this is where the scene transitions from raw exploitation into actual software engineering and user experience design.
Oh, totally.
The tools developers are building to run on top of these exploits are becoming incredibly sophisticated.
Yeah, and a perfect example in our stack is ShadowMount Plus. The documentation refers to this as an automated background auto mounter.
Which is a huge quality of life upgrade.
Seriously, because for a long time, if you wanted to play a backed up game on a modified PS5, you had to use these manual dumping tools like Dump Runner.
Right, you had to laboriously rip the data and then manually mount the files every single time you wanted to play.
Yeah, but ShadowMount Plus acts more like, An automated shipping and receiving department, or like a hyper-efficient digital butler.
I like the butler analogy.
Right. It just runs silently in the background, detects your game backup files, mounts them, and installs them directly into the standard PS5 user interface.
It fundamentally changes the user experience.
Yeah.
It bridges the gap between a hacked console and a native one,
Mm-hmm.
and it supports multiple file structures too.
Yeah, though the developer heavily recommends using the UFS format for normal use, right?
Right. UFS, or Unix file system. It's the native storage format the PS5 expects to read.
But the documentation notes they also support XFA, specifically for games that need to be tricked into thinking they are running from an external USB drive.
Yes, but there's a catch there.
A huge catch. There is this massive red warning label attached to using XFA. It says you must format those disk images with a 64 kilobyte cluster size, or the game's performance completely plummets.
It becomes basically unplayable.
But why? Like, why does cluster size dictate performance so drastically?
Well, it comes down to file system architecture and how data streaming works. A cluster is the smallest unit of disk space that can be allocated to hold a file. So if you use a cluster size smaller than 64 kilobytes on a massive game file, you are chopping that game up into millions of tiny fragmented pieces.
Oh, I see.
The console's storage controller now have to perform exponentially more read operations just to load the exact same amount of data.
So you're creating a massive bottleneck for a system that was what specifically marketed on its lightning-fast data streaming capabilities.
Exactly. You're fighting the hardware. It introduces severe stuttering and agonizing load times because the system is just choking on the overhead of finding all those tiny pieces.
Wow. But there's another, arguably scarier warning in the Shadow Mount Plus documentation.
A bricking warning.
Yes. Here's where it gets really interesting, but also a bit sketchy. The convenience of this automated mounting is amazing, but doesn't forcibly mounting and unmounting virtual disk images in the background carry a very real risk of bricking the console?
It absolutely does. You are assuming a high level of risk for that convenience.
Yikes.
Yeah, the developer explicitly warns that this process can cause severe shutdown problems and data corruption on internal drives, particularly on older firmwares.
So if the background process hangs while a game is mounted and you turn the console off, the operating system basically thinks a hard drive was physically ripped out while the disk was spinning.
That's exactly what it thinks. And that is the trade-off of operating outside the manufacturer's parameters. The safety nets are just gone.
Yeah, you're flying without a net. Speaking of pushing boundaries to improve the user experience, though, we also need to talk about Cheat Runner.
Oh, yes. Version 0.17 just dropped.
Right, and the changelog is fascinating because it focuses entirely on making this homebrew tool feel like native PS5 software.
The updates in v.17 address a lot of major friction points. For instance, they implemented a customizable controller hotkey.
Holding L2 and clicking R3 by default, right?
Yes, and that instantly pulls the Cheat Runner dashboard over whatever game you are currently playing. They also expanded the trainer menu to full screen.
Which is huge because it eliminates those cramped dialog boxes from the earlier versions.
Exactly. And they optimized the UI layers to prevent game tiles from promoting to their own GPU layers, which had been causing terrible scroll jank.
Right. But the detail in this changelog that really caught my eye was a technical fix they implemented for users specifically on firmware 4.03.
Silent failure bug.
Yes. Users were reporting a silent failure. So they would launch the cheat menu, the system would say it loaded, but absolutely nothing would appear on the screen. It was just invisible.
And the root cause of that invisible menu perfectly illustrates how fragile web-based exploits can be.
Why is that?
Because the entire Cheat Runner interface is built using standard web technologies, HTML and CSS, which are then rendered through the PS5's internal WebKit browser.
Wait, the same WebKit engine we discussed earlier?
The very same one. So to stretch that new full-screen overlay to the edges of your TV, the developer used a very standard CSS shorthand property called inset.
Okay.
Yeah, any modern web developer uses inset to quickly tell an element to pin itself to the top, bottom, left, and right of the screen.
But firmware 4.03 just flat out rejected it.
Exactly. Because browser engines on consoles are statically shipped with the firmware, you cannot update the browser without updating the entire system software.
Oh, so it's stuck in time.
Right. On firmware 4.03's specific aging version of WebKit, the inset command was still gated behind an experimental runtime flag that was turned off by default.
So the browser didn't throw an error, it just dropped the command entirely.
Yep. The overlay had no defined size and no coordinates. so it collapsed into nothing and rendered as invisible.
That's wild. It's crazy that a simple CSS layout quirk, like the kind of thing you troubleshoot when you're building a personal blog, literally broke a low-level game modification tool.
It did. And the fix required manually going through the code and replacing the modern shorthand with explicit old-school top right, bottom, and left positioning commands.
Wow.
It is a constant reminder that homebrew developers are entirely at the mercy of whatever idiosyncratic software Sony happened to ship on a specific day years ago.
Which actually provides the perfect transition to how Sony reacts to all of this, because they obviously notice when their architecture is being reverse engineered.
Right. Absolutely. Every time the homebrew community builds a new tool, it triggers a countermove from the manufacturer.
Right. And that dynamic brings us to the sudden release of firmware 13.60.
The mysterious 13.60 update.
Yeah, I found the community reaction to this update completely fascinating. Because if you look at Sony's official patch notes for 13.60, there is literally only one line of text.
Messages and usability have been improved on some screens.
Yes, that is the entire changelog. But behind the scenes, on Reddit and developer forums, absolute panic set in.
Well, the panic made sense. It stemmed from rumors that this benign-sounding usability update had actually patched the holy grail of the current modification scene.
The private zero-day kernel exploit discovered by a developer named Gina.
Exactly. And going back to our office building analogy, if userland is the lobby, the kernel is the CEO's office.
Right.
If a kernel exploit gets patched, you lose the master keys for that firmware version entirely. So the terror makes sense.
It totally does. But the sources show that Gina herself had to step in and squash the rumors. She posted on a thread stating, "Did I ever say the zero-day kernel exploit was fixed? These guys are funny. I have tons of other reports."
So what actually happened was that firmware 13.60 patched a much smaller, annoying userland vulnerability that Gina had previously reported to Sony through their bounty program.
Okay, so the critical kernel bug remained untouched.
Completely untouched.
And we don't just have to take her word for it, right? Because the sources include undeniable visual proof of this.
Right, from Echo Stretch.
Yeah, a prominent scene developer named Echo Stretch posted a screenshot showing a specific tool called KStuff version 1.09 successfully running on a console that had been updated to firmware 13.60. But I want to unpack this proof for a second. Why does a screenshot of KStuff running definitively prove the kernel exploit survived?
Well, if we connect this to the bigger picture, KStuff is a tool designed to bypass digital rights management checks by actively patching the kernel's memory and runtime.
Okay.
By its very nature, it requires deep, unrestricted system access to function. It cannot operate from userland.
Ah, so KStuff is like a canary in the coal mine, but in reverse. Like if the canary is singing, it means the vault door to the kernel is still wide open.
Exactly. If KStuff successfully boots and patches memory on firmware 13.60, it absolutely confirms that a kernel exploit exists and is functioning perfectly on that firmware.
Wow, okay. So it's a huge relief for developers. But it brings up a larger question about corporate strategy for me. Like, why does Sony use such incredibly vague language like usability improvements when they are actively patching a highly specific userland vulnerability?
That's a fair question.
Right. Like, why not just say, fixed a memory corruption bug in the WebKit parser?
It is a foundational concept in the security industry known as security through obscurity.
Okay.
If Sony were to publish a detailed technical changelog outlining exactly which vulnerability was closed, they would essentially be handing a treasure map to every bad actor on the planet.
Wait, really? Walk us through the mechanics of that. How does an update tell a hacker what to do?
It's a process called patch diffing. Researchers take the old vulnerable firmware and the new patched firmware, and they compare the massive blocks of code side by side.
Oh, wow.
Imagine comparing two massive encyclopedias to find a single paragraph that was rewritten.
That sounds incredibly tedious.
It is, which is exactly why Sony keeps it vague. If Sony says, "We fixed the CSS font parser," the researchers know exactly which chapter of the encyclopedia to look at.
Oh, I see.
Once they isolate the patch code, they reverse engineer it to figure out exactly how the exploit originally worked. Then, they weaponize that knowledge to attack the millions of consoles that haven't installed the update yet.
Oh man, so by keeping the patch notes vague, Sony forces attackers to search the entire encyclopedia blindly.
Right. It slows down the creation of new exploits.
It's a massive game of hide and seek. And, to manage all of this shifting, volatile software, users really need organizational infrastructure.
They do. It gets complicated fast.
Right. If you are constantly juggling different payloads, DNS settings, and automated mounters, it can get overwhelming. which is why the final piece of our stack today is the release of PS5 Payload Manager version 0.5.1.
A central dashboard is crucial when you are injecting multiple different pieces of custom software into a fragile system.
Yeah, and version 0.5.1 adds some fantastic quality of life features. Like, you can now favorite and pin your most used payloads to the top of your list.
That's super helpful.
It also includes visual launch indicators so you can see exactly which payloads are currently active in your session.
Which is vital for preventing you from accidentally launching the same code twice and crashing the memory hotel, right?
Exactly. But perhaps the most telling update in that changelog is the massive expansion in language support. The developer credits community members for adding translations in Arabic, Thai, French, Japanese, and several other languages.
It really emphasizes that this is not just a localized group of hackers working in a basement somewhere.
No, not at all.
This is a massive, highly coordinated global community collectively dismantling consumer hardware.
It really is. And looking back at everything we've pulled from the sources today, the sheer ingenuity of this community is just staggering.
It's impressive.
We started with weaponizing the YouTube app through custom DNS routing just to slip past the front door. We looked at how tools like ShadowMount Plus are seamlessly loading complex UFS files in the background, despite the risks.
Right.
We saw Cheatrunner optimize its UI by navigating obscure WebKit CSS limitations. And we watched developers carefully analyze firmware 13.60 to prove their private kernel exports are still viable.
It is an ecosystem defined by constant adaptation and incredible technical creativity.
It really is. But before we wrap up, I want to leave you listening with one final provocative thought drawn from the edges of our source material.
I like where this is going.
Because alongside all of these jailbreak tools and cheat menus, developers are also making massive leaps in emulation and alternative operating systems.
Yeah, that's a whole other side of this.
Right. The sources mention projects like Sharp EMU recently getting the PS5 version of Demon's Souls to successfully boot to the main menus.
That's a huge milestone.
And even more wild, on firmware 7.61 and below, there are now dedicated web panels that allow you to configure and dual boot a fully functional Linux desktop environment right on your PS5 hardware.
It completely reframes what the hardware is capable of doing.
Exactly. If this community is successfully taking this heavily restricted digital fortress and transforming it into a machine that can dual boot a Linux operating system, run complex automated scripts, and emulate its own specific console games, what really defines a console anymore?
It's getting blurry.
It really is. If you can do all of that, are we rapidly moving toward a future where the line between a strictly controlled game console and a fully customizable open source PC simply ceases to exist?
It is definitely something to chew on.
It is. Keep your curiosity alive, keep questioning how your technology actually works, and thank you so much for joining us on this deep dive.